Good afternoon, grade 7. Welcome to our asynchronous lesson. Last time we discussed about the scalar and the vector. Now, let us discuss about the distance, speed, and acceleration. Let's begin. You were able to help Peter find out the length of the path covered by different routes from his house to his school. What you actually computed is the distance from Peter's house to his school, right? So, ang hinahanap dito is distance. So, distance is simply defined as the total length of the path covered there from one point to another. Distance is a scalar quantity. Do you remember? Distance without direction is scalar. Vector if it has a direction. Next, for route 1, the total distance covered is equal to 140 meters. For route 2, the distance covered from point A to point C is equal to 100 meters. So, the distance is the shortest path covered from the initial position or point A to the final position, which is the point C. The shorter distance or the shortest distance covered by an initial position to the final position called the displacement. Okay? Displacement is a vector quantity as you recall. Okay? Displacement is a vector quantity. Hence, displacements require direction for a route 2. The direction is from point A to point C or southeast. So, the distance and the displacement can be expressed in any unit of length such as meter, inches, feet, and kilometers. So, you were at you were able to help Maria to find out how fast the school bus traveled from her house to her school. How fast an object travel actually describe the speed of the moving object. Okay, let's resolve this. They need speed. Speed is simply the result when you divide the distance covered by the time which the object has traveled. Okay. In equation form, average speed total distance okay, is equal to total distance divided into time. Okay? Or in symbol, V or average speed or velocity equals to distance over time. From the previous activity, you were able to find out the distance covered by the bus is 60 kilometers and the total travel time of the bus from Maria's house to the school is 2 hours. Okay? So dividing the distance by the time will give you the speed of the bus, which is equal to 30 kilometers per hour. Speed is the scalar quantity. You were also able to observe that the direction in which the bus traveled from Maria's house to the school is to the right. When you describe the speed of the moving object together with the direction of its movement, you were actually describing velocity. Okay? Hence, velocity is simply the speed of the moving object with the direction of its movements. Okay? So, in equation, average velocity is equals to displacement divided into time, or in symbol velocity, displacement of velocity or average displacement of velocity is equals to d displacement, which is d with the arrow head, over t. Okay. From the previous activity, the velocity of the bus is 30 kilometers per hour to the right. Okay? Speed velocity can be expressed in any unit of distance divided by the unit of time, such as kilometer per hour, meter per second, and miles per hour. We have here the sample problem. A car going north has traveled a distance of 80 kilometers in a span of 2 hours. What is velocity of the car? So let us solve this. So given, what are the given? So D is equals to 80 kilometer, or displacement, or the distance. T, or the time, is equals to 2 hours. Required to find is the average of velocity's displacement. So the equation is like this. V with the arrowhead average is equals to the arrowhead distance of displacement over the time. Solution, let us put uh, the quantity, which is for the distance is 80 kilometers and for the hours is 2 hours, or for the time. So the answer is 40 kilometer per hour to the north. Okay? Next, you were able to help Lance to find the rate at which the car changes its velocity. The rate at which an object changes its velocity per unit time describe the acceleration of the moving object. So, in equation form, average acceleration is equals to change in velocity over time, or average acceleration is equals to final velocity minus initial velocity over time. Okay? Or in symbol, okay, A with arrowhead average equals to B with a sub of F minus V with a sub of I over T. Okay. From the previous activity, you were able to find out the initial velocity of the car at the point A is 5 kilometers per hour, while the final velocity of the car at the point B is 55 kilometers traveled east. Hence, the change in velocity is equal to 50 kilometers per hour. The time which the car has traveled from point A to point B is 2 hours. Okay. Dividing the value of the change in velocity of the car by the time it has traveled will give you an answer of 25 kilometers per hour is, or 25 kilometers per hour squared is, which is the acceleration of the car. Acceleration is the vector quantity. It requires both magnitude and direction. It is also important to note that the change in velocity can happen into two ways. So what are the two ways? Two ways by which a change in velocity can happen: by changing the speed of the moving object in a straight line, by changing the direction of the moving object while traveling at the constant speeds. That are the two ways. So Thus, when a moving object in a circular path with a constant speed, its velocity changes because of the change in direction of the moving object. Consequently, the acceleration of that moving object also changes. I have here again an example. A boat going south started sailing with a velocity of 10 km per hour. What is the acceleration if the boat traveled for 3 hours with a final velocity of 40 km per hour? So, okay, this is the solution. From the given, the initial velocity is 10 km per hour. The time is 3 hours. The final velocity is 4 km per hour. So, ano yung ginahanap natin? Acceleration, the average of acceleration of displacement. Okay, so B sub of F minus B sub of I over time. So 40 km per hour minus 10 km per hour is 30 km per hour. Down lang natin yung 3 hours. Okay, then 30 km per hour divided into 3 hours. Okay, the answer is 10 kilometer per hour square. Okay, before I end this session or lesson, I have a thought to ponder. There, there is more to life than increasing its speed by Mahatma Gandhi. Thank you for listening. I uh, I hope that you learned a lot from me now how to solve the initial velocity, the final velocity, the acceleration, the speeds, the distance, and etc. So next meeting we will going to discuss more about physics. Thank you for your time. God bless you, and goodbye, everyone.